In example 2, we have one of my most favorite properties of all of algebra, the distributive property. And what we want to do is we want to use the distributive property to write an equivalent expression. So an expression that has the same value as the original one, but it's going to look a little bit different. This very first one, I'm going to give you a very quick understanding of why the distributive property works the way it does. And so if I wrote this here on the top, if I wrote 4 times 3, a very basic understanding of 4 times 3 is that we're supposed to add 3 4 times. Or, I mean, you could also you could add 4 3 times as well. That would be fine. This will work though. 3 plus 3 is 6, plus 3 is 9, plus 3 is 12, and some of you already remembered this fact that 4 times 3 is 12. So if you write it out, that's a great tool, but if you do remember how to get that answer using just 4 times 3, might be even a little better, a little quicker. The distributive property is kind of like that. It's a little quicker than having to write the whole thing out, but when in doubt, write it out. So let's see if we can do that with this problem here. I want you to see that when we have a 4 here, or any number, or any term or expression for that matter, and we have just a set of parentheses on the right, we're really multiplying that together. So in reality, we need 4 y plus 3's. So we've got y plus 3, a y plus 3, and we're adding a y plus 3 and a y plus 3. If we count how many y's there are, there's 4 of them. And if we count how many 3's there are, there's 4 of them, where 3 plus 3 plus 3 plus 3, we said, was 12. So writing this out, we know the solution to this. If we, well, it's not really expanded, I guess, but if we just use the distributive property or try to perform this operation here, we're going to get 4y plus 12. To use the distributive property, whenever you have a number that's outside, or a term that's outside a set of parentheses, you can just take that term or that number and multiply that by the first term you see. So that's 4 times y, or 4y, and take the 4 and multiply it by any other terms that are inside. In this case, there's only one other one to worry about, and it's 4 times 3, and that's 12. If you forget to multiply the 4 times 3, you're losing, or I guess in some places subtracting value, or adding value. Some weird stuff happens. You just don't do it, okay? If you want to write it out, you can, but I think you'll find that the distributive property, if you can remember that, becomes very easy. It can be hard to write it out when you've got variables involved, so you're going to want to use that distributive property in an example like 2. We've got this term, this variable on the outside of a set of parentheses, and we've got more than one term on the inside, so we know we have to use the distributive property. So we're going to multiply y times 7, which is 7y, and then we're going to multiply y times y, which is y squared. Kind of like if you had 2 times 2, you could write that as 2 squared. But in this case, we couldn't actually figure it out. Like 2 squared is 4, but we could do y times y, and we could list that here and write that down as y squared. In the third one, we've got n times n minus 9. So we know here that the structure of this tells us we need to use the distributive property. Be very careful when you have a term, a variable, a number on the outside of a set of parentheses and more than one term on the inside. So we've got n times n, that's n squared, and then n times negative 9, that's negative 9n. Be very careful also with your signs here. This is a positive n, and a positive times a negative is totally a negative. Number 4 is sort of like the number 2 there. We've got the 8 and the y here on the right hand side. It makes no difference. We still know that we're multiplying these two. There's a hidden sign, I suppose, right there. Understood that we're multiplying. So we need to multiply every single term that's on the inside here. So we've got a 8 times 2, which is 16. And then a positive 8 times a negative n, which is negative 8n. If you'd like to list this as negative 8n plus 16, that'd be fine. Keep in mind that this 16 is positive here. That's why we have a plus sign. Either one of these is okay for now. Just a few more examples to do. The distributive property is great. Love it. And 5, we've got 2, and then in parentheses, x plus 3. So we'll do the distributive property here. We'll multiply the 2 by the x, and the 2 times the 3. So we've got 2x plus 2 times 3, which is 6. Maybe you're catching on, and just so you know, that the most often made student mistake with this is just forgetting to do the actual distributive property. And I think probably the second most often understood or most made mistake here is on number 6. This negative sign is here and there's no number there. So if it helps you, you can think about this as negative 1 times the quantity here of 4 minus y. You do need to distribute this negative 1. So negative 1 times positive 4 is negative 4. And then negative 1 times negative y, negative times a negative is a positive, 1 times y is just y. The negative does not belong only to the 4, but we need to apply it also to everything else that's inside the parentheses here. If you'd like to write this as y minus 4, that's okay as well. Oh darn, only 2 more here. Shoot, wish we had more examples. Alright, well we'll just knock these out then. M minus 5 and then negative 3m. So we have 2 terms inside here in this set of parentheses, and we only have 1 term on the outside, so we're going to need to distribute this term to each one of these 2 on the inside. So we've got a negative 3m times m, so if we look at the negative 3, that'll stay, and then m times m is m squared. Negative 3 times negative 5 is positive 15, and there's an m left. In number 8, we have a little fraction to deal with. We have some nice numbers inside the parentheses though, so we'll do our 1/2 times 2n and 1/2 times 6. 1/2 times 2, or 1/2 of 2, is 1. We have an n, and then 1/2 of 6 is 3. We would not normally write this with a 1 here. It's a good idea to clean that up and just make that an n plus 3. It's understood that the 1 is there.